Let's take a look at another functional equation from a solid problem of the International Mathematical Olympiad 2002. It says find all functions f from real number to real number such that f evaluated at f of x plus y equals 2x plus f evaluated at f of y minus x. So let's call the original functional equation p of x comma y. So the first step, we would like to prove that f is a surjective function. In order to do this, we can try to make the argument on the left side to be a constant number. Okay, so we can just pick y to be negative f of x, which means we could pick p of x comma negative f of x. Okay, so here we have f evaluated at f of x, and then y will be negative f of x, and then equals 2x plus f evaluated at f of y will be negative f of x, and then minus x. Okay, so here we can observe that this one is actually a 0, so we have f of 0 on the left side equals 2x plus f of, this one looks horrible, but we don't really care what it is. We simply denote it as a triangle or delta. So in this case, we can have f of delta equals negative 2x plus f of 0. And since f of 0 is a constant and x can take arbitrary real value, which means that the image of the f should take all the values in the real number, which means f is surjective. Okay, so this is the important step for this functional equation. And next, since f is surjective, which means we can assume there exists a number x sub 0 in real number such that f of x sub 0 equals 0. Okay. And now we can just pick a p of x sub 0, y. Then we will have f evaluated at f of x sub 0 plus y equals to x sub 0 plus f evaluated at f of y minus x sub 0. Okay, since f of x sub 0 is 0, so we can just cancel this term, and then on the left side we have f of y equals 2x sub 0 plus f of evaluated at f of y minus x sub 0, like this. Okay, so it looks like we get stuck here, but actually we can have another assumption, which is like for all z in real value, there exists y in real number such that z plus x sub 0 equals f of y. Originally, when we try to use the surjective condition, usually we might not have this term, which is like for arbitrary z in real number, there exists another number also in the domain such that f of y equals z. But after adding x sub 0 on the left side, this one is still in the range, so we can also find a number y such that f of y equals z plus x sub 0. And then quickly we can see why we make this assumption, why we need this x sub 0 here. And we can try to put x sub 0 over, so we have z equals f of y minus x sub 0. And then we can try to put this one in here, and also we put this one in here because we have f of y here, so we can change it to z plus x sub 0 equals 2 x sub 0 plus this one is actually this one, so we have f of z on the right side, and here z is arbitrary number in real number. Okay, so here we can just cancel x sub 0 with this one. So finally we have f of z equals z minus x sub 0. Or actually we can just write it as f of x equals x plus a constant k. Although this is a negative x sub 0, but we can just call it another variable, just like plus k rather than negative x sub 0. So this one should be the solution for this function equation, and we could try to check this one out whether all the solution satisfy the original function equation. So we try to check. The left side is f evaluate at f of x plus y. This one will be f evaluate at x plus k plus y equals x plus k plus y plus k. Okay, so we will try to see, we try to add x and then subtract x. So we have 2x here to match with this one, and then plus, here we have y plus k. So we have y plus k, and then we should have negative x, and then we still have plus k. So we can consider this one here to be, this one is x, so this is x plus k, so we have f of x, so which is like 2x plus f of y plus k minus x. And then here we can just reordering it, so we have f of y minus x plus k here, so we can put them in the parentheses. So here we have sorry, it should be like it should be like put these two terms in the parentheses. So we have 2x plus f evaluate at f of y minus x. So this is okay, and of course f of x equals x plus k is the solution to this function equation. And that is the end of the video.